Hi and welcome to Ultimate Stream Live. My name's Steve Helliker from Ultimate Stream and we're a hi-fi dealership based in Surrey in the UK. Amongst a range of hi-fi products that we sell, we specialise in streaming solutions and active speakers. And I'm delighted to be joined today by Eelco Grimm from Grimm Audio to talk to us about the digital streamer that they produce, the MU1 and the LS1BE active loudspeakers. Hi Eelco, welcome to Ultimate Stream Live.
Hi Steve, thank you so much for having me. It's a big pleasure.
It's great to have you back again. Eelco, perhaps you can start off by telling us a little bit about your background and the background to how you started Grimm Audio.
Sure. Well, Grimm Audio was started in 2003, so that's 19 years already. Officially, it was 2004, but of course, we started in 2003. And it was with Guido Tent, who's still with me as a partner, and Peter van Willenswaard. We are friends together from the 80s already. And then Bruno Putzijs also, who was at the company at the time. So Peter and Guido and I go back all the way to the 80s when we actually, Guido and I discovered high-end audio through a magazine for which Peter wrote, which is called Audio and Techniek, Audio and Technology. That was run by John van der Sluis. And that was a magazine where there were comparative tests between equipment. And also they did a lot of measurements and they tried to find out what made a certain piece of equipment sound good or not good. And then at a certain moment, they, especially Peter, dove into a new world, so to say, of the rediscovery of tube amplification. And that was such a big adventure because he described what it emotionally did to him. And it was like finding a lost knowledge, so to say, or a lost asset that audio equipment was able to transfer the emotion that is recorded much better to the listener than with the solid state electronics of today. And so he didn't expect that. And so his writings were like a big adventure into new territories. And that was very addictive to read. And so both Guido and me got attracted to that. And we connected to the magazine. I had an internship there. I was studying electronics at the time, but moved to the conservatory to study music recording and also sonology. Sonology is like, has to do a lot with the electronic composition styles and knowledge and backgrounds like sound acoustics and synthesis, etc. At the conservatory in The Hague. So I was already around that time moving from more general electronics into audio and audio recording. And Guido was still more focusing on audio engineering. So my personal move was towards professional audio, and Guido stayed developing hi-fi equipment. I make it very brief. And so what we met at the magazine and the shows that they did, and we had a great time together, learning a lot. After my studies, by coincidence, I managed to get a job at another magazine that was founded by Hans Beekhuizen, who some of you might know from his YouTube channel. At the time, he had a magazine called Pro Audio Magazine, and he founded it together with Peter van Willenswaard, who at that time, which is in 1991, Peter had moved from Audio and Techniek to Pro Audio Magazine. And that's where Peter and I really became friends, and I learned a lot from him about measurements, etc. And a couple of years later, in 97, I founded my own recording company called Fairy Tapes, just a one-man band affair, of course. And Peter and Guido, they helped me to build the equipment for my little acoustic recording adventure. And we built microphone power supplies for my tube microphones, microphone preamplifiers, a mixing desk, and at a certain moment we were building an analog to digital converter, discrete based on certain chips. We were learning, and we then saw that a certain Bruno Putzijs would give a presentation for AES in Amsterdam, and that was in 2003. And so Peter and I figured, yes, wow, this is the guy who can teach us a lot about the problems that we encounter with these analog to digital converter designs. So we went there, and after the presentation, we immediately talked to Bruno about it and said that we loved his presentation. We really would be happy to license his design. And then he said, oh, well, I would love to also team up with you and start this whole adventure together. So that was actually the real start of Grimm Audio. So in a way, it was founded in the friendship we had, Peter and Guido and me, and the recording company Fairy Tapes that I had myself. And then it gradually turned into building equipment, not just for myself, but also for, customers. And then in the meantime, Grimm Audio took over, and so I don't do much recording anymore.
So I guess that you can see from this, with the relationship that you have with Guido, that you've got the studio side and the home hi-fi side, because we see
right, exactly,
a lot of your products in recording studios as well as in the home.
Both Peter and Guido have much more a hi-fi background, and I have a pro audio background, Bruno a little bit in between, and so that was a really great team. But of course, yeah, it was based upon dreams, and at a certain moment it became reality, and reality is always quite different from dreams. And so, but now we are 19 years further, and it's now a very serious company. At the company, we really see this as one big continuum. So we see it as a chain of audio signals. So you start, of course, with the recording acoustics. You can do maybe some advices there. I was an acoustic consultant for a while, in the early 2000s till maybe the 10s. And then the next step, of course, microphones, and then cables, and then microphone power supply, maybe if it's a tube mic, microphone preamplifier, an analog to digital converter, and then you're in the digital domain. You might want to have a look at the signal levels. We have plugins for studio use to inform you about the loudness of your signal. We have this analog to digital converter combined with digital to analog and monitor functions, which is called our UC1. So that functions as a kind of central stage, not so much, to be honest, for recording, but it's really the centerpiece of a mixing and mastering studio. So then we go onwards, and then in the medium, the medium, you might say, is transparent, but there is a lot of culture for the medium, like for instance, how loud should I make my master? And I've been working on fighting the loudness from about the same days that we started Grimm Audio. I think Grimm Audio was founded in 2004, and my first loudness adventure started in 2005, where I joined eventually the EBU and AES to work on recommendations both for broadcast loudness and for now streaming loudness recently. So the AES standard for streaming loudness. That medium, if there's loudness normalization, you don't win if you make a loud master. So it doesn't matter much if you master loud. So let's make dynamic masters, and so music will sound way better, which is, that's really a passion for me, to make sure that people will produce beautiful music and beautifully recorded and mastered music. Okay, well, then of course the consumer side starts. then there is a file on a server, and you can have a subscription to Tidal, Quotes, Apple Music, Spotify, whatever you have. And of course, we love the lossless versions of that, so you have the pristine quality of the original. And you enter the room of the end customer, the user, the listener. And so again, the MU1 is the product that we offer for that. It converts the files from an online server or your local files into a digital audio stream that you then connect to loudspeakers. The final step, of course, is the acoustics of your room, and then we are in your ear. That's a full chain, and we really believe in looking at all parts of that chain.
And I guess you're like me, you're lucky because I've got a passion for music and hi-fi, and it's my work, and I guess it's the same for you.
Absolutely.
You're based in Eindhoven, or very close on the outskirts of Eindhoven.
This town is called Veldhoven. It's very much technology oriented and manufacturing in this area.
And you teach as well?
I indeed teach. So when I quit that magazine of Hans Beekhuis, in that Pro Audio magazine, that was in the year 2000, I was still had the dream of working more as a sound engineer. Also, I loved explaining stuff to people through the magazine as a writer. I figured, well, maybe teaching is also nice to do. So I applied for a job at HKU University of the Arts in Utrecht. I live in Utrecht. And I got that job. And I still teach there. So that's 22 years now. I enjoy myself a lot in teaching. It's very much fulfilling to see these young people find their own way into art and music and technology. So I teach both the first years until all the way to the graduates and even master students. So it's just 1 day a week still, but I really love doing that. I don't intend to quit that. It also gives me energy and inspiration.
Well, I said we were going to talk a little bit about the MU1, your digital streamer. You mentioned that you've done some writing. Let's just look at what a few people have written about this streamer. So there are a few quotes here that I'm going to read to you. 5 stars for the MU1. MU1 opens up new musical words. MU1 is digital nirvana. Diamond Award for MU1, rediscovering music, extremely addictive. I mean, the quotes just go on and on and on. So it's clear that this is an outstanding product. How have you managed to achieve this in its design and production? First of all,
a very important thing is that it's not just me. That's very important to underline. It's a team effort, and especially the MU1, very, very much a team effort. So what I wanted to have was a simple unit that was a joy to use and that would sound fantastic, and that would integrate all the functions that I would like to have in a living room. Of course, also my own living room, and also with the speakers that I have at home, which are LS1s. The LS1s have digital inputs on AES EBU, and that's combined then with control data. So we don't use an XLR, but we use a Cat5 connector that can carry both the AES EBU and the control data. And so one of the things is we want a button to control the volume of a connected LS1 in this case. What I also wanted is to integrate a music source into this device. And that music source ideally would connect not just to local storage, but also to storage from the internet, like Tidal Stream. And one thing that the metadata that comes with the audio, and that says what is the name of the album, what's the name of the artist, who are playing on this album, who's the guitar player, who is the producer of the album, all that kind of stuff. That metadata is really gold if you can access the metadata and combine it. So like you listen to a song, you think, oh wow, that bass player is just great. I want to hear other work or other albums that he worked on. And then a guy who we talked to about this streamer, he said you have to go to this new introduction at the Munich high end, which is Roon. And Roon was introduced after this engineering team separated from Meridian, where they had been working on Toulouse. You have a Roon core inside, which makes it nicely integrated, because usually you need a second computer or an external computer to run your Roon core. But in the MU1, the Roon core is inside, so we have an NUC computer running there with a very high quality power supply, so it doesn't interfere with all the audio stuff. Then we have a local storage of audio. You can connect to the internet, of course. And there's extra digital inputs also for, let's say, a television or a CD player. Then that NUC connects through PCI Express at a very high speed to our, let's say, audio card, sound card. And the sound card has an FPGA processor on it. And on that FPGA processor, there are algorithms running that. What's actually happening there is two things. One is the audio oscillator is on that board, and it's integrated with some of the FPGA code. And you have to know that Grimm Audio, in the early days, actually when we founded the company, we recognized the importance of very low jitter clocks to reach, let's say, more analog like sound in digital. If you slave the device to an external source, which is not Roon, you need to have a circuitry inside that can synchronize the internal clock to, let's say, the clock of the CD transport. So that's also taken care of by the FPGA. So that's one function of that FPGA. And then the second function is a conversion that we perform in the digital domain from the original internal sound file format to the format that we send out to the connected either LS1 or DAC that you can connect to the MU1 as well, because of course, as you all know, the MU1 can be used with any DAC and not just with LS1s. If you connect your music streamer to an external DAC, you can do that in various ways. Usually, people use a USB connection, but also, let's say with Roon, you can use a network connection, and then the DAC receives that signal, whatever bit rate it has, maybe high res, maybe DSD, whatever. But the beauty of the device is in the FPGA board, and the output of the FPGA board is just XLRs for AECU and an RCA for SPDIF. So why did we choose those outputs if all the others choose USB or network? Well, the reason is that clock. The clock that I just mentioned has such a good performance with such low jitter figures that you want to have your DAC take advantage of that. But that means you have to transport that clock downstream to the DAC. And the only practical way to do that, that's available on almost every single DAC in the world, is by using SPDIF or AECU. Because if you use USB, you can transfer the data, but you cannot transfer the clock. And that's just part of the technology. The design of the technology is such that with USB, the DAC will be master clock, and it will ask you samples from the computer. Whereas we want to be the MU1, be the master clock of the system, and then the DAC slaves to the master clock, effectively adopting the jitter quality of the MU1 clock instead of being dependent on the clock quality of its internal clock. If you limit yourself to ASDDU and SPDIF, you know that the maximum sample rate that you can transfer from your MU1 to the DAC will be 192 kilohertz, because that interface doesn't support higher sample rates. So I knew when we made that decision, and also the same decision has to be made for the LS1s because they also have an ASDDU input. And I knew that if you would then like to play DSD files or DXD files or whatever you will have at the high res, you had to transform those formats into a format that fits on the AES connection, which is maximum 192 kilohertz. And that's where the FPGA code steps in. And then, more or less to our own surprise, a bonus steps in. Because if you have those algorithms running, you cannot just downsample the high res, which is needed if you want to use that interface. But you can also upsample the low res, which is not necessary. Of course, you can send just a 44.116 file over AES-EBU. You can just read it from the disk and send it out to the DAC. But with the same or similar algorithms that we are using running on the FPGA, you can also upsample or upscale, or how do you name it? And so the first step of upsampling from 44.1 to 176.4 is done on the FPGA board. And then we again connect to the external DAC. Now you could say, why would you want to do that? Because the DAC has a built-in scaler, has a built-in upsampler, so it could do that itself. You don't need to take that out of the hands of the DAC. It's perfectly capable of having an internal upsampling. So why bother? Well, what we discovered is that, especially in DAC chips, which is, well, what the vast majority of DACs have, the processing power that's built in that chip, plus the algorithms that are used, are not of the highest quality and not the smartest that you can imagine. And the first step, let's say usually such a chip runs at a couple of megahertz internally, and then they upsample from 44.1 to that couple of megahertz, but they do it in steps. So the first step is, let's say, to 176.4, and then another step yet to 500 kilohertz. I'm just thinking out loud. And then they finally go to the internal rate of 5 megahertz or whatever it is. Then we discovered that if you replace the first step that's usually done internally in the DAC by our algorithms in the FPGA, there's an interesting quality increase. Apparently, that first step is the most difficult one to do. And so that really was a surprise to ourselves. But that's part of that, all the great results we achieve with the MU1 and all the acclaims we receive from reviewers has to do with that fact that it's a combination of that low jitter and the high quality upsampling, scaling, how you would like to call it. It's all. And
with the upsampling, you're given a choice to 2 times or 4 times oversample.
Right. Yeah, the origin of that choice is actually that some of our customers said, my DAC is not able to support the 4 times upsampling that you offer. It can't lock to 176.4 or 192. And then in one of our updates of the firmware that's come about 3 or 4 times a year, we added a 2 times upsampling option. to cater for that kind of DACs. But usually we recommend to always put it on 4 times over center. Yeah.
With Rune, one of the things that they introduced, I think a couple of years ago now, was putting Tidal and Cobuzz into the software. So when you're listening to your music, you've got a choice of using your own music in your own library or streaming from Tidal and Cobuzz, and that's all integrated together.
This is what you want. You want just a single interface that inspires you by saying, hey, if you like that, you might also love to listen to that track. And with one click, you can, like I said, check out who's that bass player and show all the tracks that he's playing on. And then it integrates all that with both your locals albums and the online audio or albums that you find on Cobuzz or Tidal.
With the MU1, you've got the option of having storage built in as well, and you've developed the software and the user interface in the MU1 for the customer now, because you can basically control it from an iPhone or an iPad through a web page. So you can basically scan a QR code on the front display and then have control over the upsampling and the other controls on the unit.
I can actually show that to you here. And on this iPad, I have opened the web page of this MU1. And on that web page, you can see there's buttons to control the source, to select the source, to control the volume. But there's also information about the track that's currently playing. Now, that's just a copy of what the Rune interface will tell you. But it's just convenient to also have it in the remote of the MU1. Now, there's a button that says MU1. If I click that, a window opens that gives you all kinds of settings of the MU1 that you can change here conveniently from the listening chair. And if an LS1 set is connected to the MU1, there's another button called LS1, and you can also set up the LS1 system. So stuff like maybe some EQ settings. There's some smart EQs in the LS1s to cater it a little bit for your acoustic surroundings. You can all set that up from your listening chair. Yeah, and that kind of software that you see here, that's all written here internally. We wrote our own web server even for the MU1. But this is just part of the software. This is the most visible part. But internally, there's a lot of software running. We have the Rune software running, of course. That's a part that we did not wrote ourselves, but it runs on a Linux operating system, and that Linux operating system is highly optimized by our engineers. So it's a tiny core Linux operating system. There's no graphical user interface at all. We have that web server running. We have all kinds of extra code to turn on and off the machine on an extra microcontroller. There is, of course, that whole FPGA that has lots of code running for the digital signal processing of the audio. The whole device needs to be controlled, like the volume control, like all that stuff. Start and log out, etc. All that code has been developed here in the house, and so that's been really a lot of work. There will be an update coming out pretty soon that will add some interesting features, like often on customer requests, we have 4 outputs on the back. The reason is that you can build a surround system with it. It can be with LS1s. It can also be with third-party loudspeakers and amplifiers and DACs. There's no DAC inside, it's just digital outputs, but you can play back surround files and you can connect it to surround DAC. But that also offers another opportunity to connect 2 DACs for different purposes. Like one DAC, the output goes to your loudspeakers, and the second DAC has the built-in headphone amp. And you see that kind of converters often these days, and they're sold quite well with very high quality headphones. Now, a customer asked us, I would love to be able to switch between my headphone and my speakers in a convenient way. So in the upcoming update, it's a matter of telling that software that I just showed, I want to have a second output on AES Out 2, connect the headphone output to that, and then if you double click the button here, it will switch between that output and the main output back and forth. You can also say, I want to have this source at a certain standard volume setting and that source at another standard volume setting. And next year, we will also continue with that, adding stuff like a UPnP DLNA renderer. We are working on Tidal Connect. We will also add an official room endpoint to the MU1 that has some small advantages and make the setup a little more convenient. So there's continuous development going on. Software development is, I think, the biggest department in this company.
And talking about development, I believe you're going to be launching the MU2 next year as well?
The biggest difference with the MU2 is hardware. So what is the MU2? We plan to introduce it at the high-end Munich in May. It looks similar. It's the same box, so you will recognize it immediately. But it says MU2, and the back is totally different. The MU1 is intended to be used with third-party DACs and with loudspeakers with digital inputs like the LS1. And the key and Dutch and Dutch and whatever Channel X. There's many loudspeakers that have digital inputs.
Yeah.
So the MU1 will always be here. So let me first clarify: the MU2 will not be the successor of the MU1. There will be two models, MU1 and MU2, and they serve different purposes and different customers. So where the MU1 has digital outputs, the MU2 will have analog outputs. And just like the MU1 does not have an analog output, the MU2 will not have a digital output. So that's it's in short, it's a music streamer with built-in room core, etc., like the MU1. You can connect your television and your CD transport digitally, just like with the MU1, but that's the inputs. There's also analog input. So let's say you have a phono preamp, or you have a tape DAC that you want to listen to. You can connect it through RCAs or XLRs. And then the outputs are analog. So that those inputs, those analog inputs, are not digitized. So that means that the volume control is also analog. So with the MU2, if you turn the disc, you will hear relays clicking because there is a relay-based analog volume control inside. So it is a preamp. But it's a preamp combined with a high-end DA converter and a streamer and a core. So it's a complete audio system in this form factor, in this very small box. The only thing you need to add still is power amplifiers and passive loudspeakers, or maybe analog active speakers, and that's it. And that integration of function is key to most products that we develop. And the MU1 with the LS1s is an example of fantastic integration, because this is really everything you need. You don't need any other box. The storage can be inside. You just need a router that you probably already have to hook up your internet connection, and that's it. Then you have a complete high-end audiophile system. Now with the MU2, we approach that except it's for people who rather keep their passive loudspeaker and their amplifiers, but they love to have a wonderful sounding DAC that is intended to at least be at the level of the best DACs that you can buy at this moment. We aim to be better than that, but that the verdict is, of course, for the reviewers. And then combine that with a Roon core, Roon endpoint, analog inputs, digital inputs. So yeah, well, everything. Headphone built-in headphone amp as well. So.
Oh, thank you for sharing that with us. I guess if you're going to be showing that at Munich, which is in May, then production will be sort of what, late summer, early autumn?
Autumn in September, indeed. Yeah.
So we've talked around the MU1 and the MU2. The other product that I wanted to focus on, well, two products really, is the LS1BE and the SB1 active motion feedback subwoofer. The reviewers all say, and certainly from my listening, the LS1BE is an incredibly natural and it has a very transparent sound.
It's the intention of the speaker to be both neutral and musical. The neutrality stems from the original intent of the LS1, and that is to build a loudspeaker for studio use, on which you can make all the decisions that an engineer makes about equalizer settings, compressor settings, etc. So that means that we were aiming to build a loudspeaker that is very linear in the frequency range and very linear amplitude-wise. Many speakers, if you play them louder, they start to distort more. Our speaker stays distortion-free, and at a certain moment it just crashes in a way. But then you're playing very loud. And so it's very long. There's a long dynamic range in which it is very natural and open sounding, and we selected the drivers especially for that. Now, if you just buy the right drivers and put nice amplifiers in the box, and you design the box in the right way according to all the theories, you will never be able to make a speaker that has a perfectly linear amplitude response, so that all frequencies are equally loud. And for a studio, that's actually what you would need. You don't want a loudspeaker where that always emphasizes a certain frequency band, because then you need to learn that that band needs to be emphasized in your mixes, and you should not correct for that. And I didn't like that as an engineer. It also always made me nervous. I wanted to have something that I could trust. So I wanted to have a loudspeaker that has a relatively flat frequency response. Now, that's very difficult to do in the analog domain, especially with passive speakers. But it's when you turn into digital processing solutions, that's much easier to do. In fact, it's so easy that you can just put up a mic and say, okay, measure the speaker and make it a straight line, and then you get an inverse filter of the filter that you measured, which is the actual loudspeaker. And then you say, okay, correct for that, and then you measure again, and voila, a straight line. But the problem is that if you move the microphone just a couple of centimeters, it will be worse than it was before you did the correction, because you will have the problem of that position plus the correction of the other position. So that was not the idea we had to approach this problem. So it was still with Bruno Putzijs, was at the company when we developed the LS1s. And Bruno and I had the idea, okay, let's think about what a loudspeaker should do in the first place, and then build it up from there. And so we didn't look too much at other loudspeakers designs. We thought, okay, let's approach this from an acoustic standpoint. And from an acoustic standpoint, a driver generates sounds and then the first obstacle it finds is its own box. So the sound has to go around the edges, etc., of that box, but it's an obstacle to its own sound. So it will form the projection of the loudspeaker and the way that the sound wave evolves in space. So if you know that, and you think about the frequencies at which that happens, you look at the standard loudspeaker, you see, okay, it's usually a size like that, usually the width of the woofer, but that's a frequency that's relatively high. So to make it less abstract, a standard box will usually project frequencies above 600 hertz hemispherically to the front, and below 600 hertz, more omnidirectional in all directions. And we figured, why 600 hertz? It doesn't make too much sense. It's in the middle of an important frequency range where everything between, let's say, 200 hertz and 600 hertz still matters a lot and should be integrated with the whole spectrum, but you're kind of changing the acoustics for the higher frequencies from the acoustics of the lower frequencies. And if you know that that is done at a certain frequency, which is called the baffle step, why would we select 600 hertz for that? And so we thought, what would be a better frequency than 600 hertz? And then we knew that in a room, a listening room sized room, there's usually all kinds of room modes, as it's called, resonances of the room, and they dominate the frequency response up to about 200, 250 hertz. And then above that, you can talk sort of reverb and reflections, and below that, you can talk about resonances. So to have a baffle step around that frequency seemed to make much more sense. You could go lower, but then you would end up with a way bigger speaker. So 250 hertz seems like the best compromise. And 250 hertz happened to be this size. It's about 60 centimeters wide. And then, of course, you have sharp edges if you have a standard box. So to avoid diffraction there, which can cause another problem, we rounded the edges. And then Bruno and I decided to take those rounded edges all the way to the floor, and that forms flags. So the whole form of the LS1 is very much function driven. So its form follows function, and that's why after 11 years we still build LS1s and varieties of it, but the basic form is still the same.
The LS1 was released in 2010, and the look of the speaker is pretty well the same now as it was then. It sounds very different because of all of the improvements you've made.
Right. So the improvements are in electronics, in driver choices, but the cabinet design was really thought out well at the time, and we stick to it because it really works and it does exactly what we want. However, if you have that cabinet and you put drives in it and you just use it as a passive speaker, it doesn't sound good because the drivers were not developed to be used in such a wide cabinet. There's lots of stuff not going well. We decided to use a small waveguide on the tweeter, but that also means that there's a roll-off in the top end of the tweeter because that energy is dispersed in other directions. Now, if you use it passively, it's a nice speaker, but not a rocking speaker. So if we then take the DSP, the digital signal processing, to that, and we use digital signal processing both for the crossover between the tweeter and the woofer and the subwoofer, and to linearize the response of the drivers in a smart way, we went to an anechoic chamber. We measured outdoors just to know that the full frequency range was correctly measured and compensated for. And what we learned over the years is to be very careful with the correction filters. So we learned how to do that. We now have computer-aided calibration tool. So the operator, he measures the system, every single LS1 in the factory, and then the computer does some proposals for correction filters, and the operator says, okay, I want you to go more in that direction and in that direction, and then it calculates another 1,000 options. That's much faster than doing that manually, but you still have the human input on that. And then what you then end up with is quite linear, not perfect linear, but a very much linear frequency response within 1.5 dB. We don't shave off the hairs, as we say. We leave certain effects there because we know that it's dependent on the position where you are measuring, for instance. And that brings us a very transparent sound where every frequency is treated the same. So you can hear an instrument in its natural way. And you can make your mix decisions. And then by not overdoing the processing, we make sure that it still sounds musical. And then, of course, to that, we add the low-jitter clocking, the high-performance digital to analog converters, the whole analog part where we are careful about selecting the components and the circuitries themselves. The power supply regulators that we are famous for, etc. And that's again, it's all a team effort of the whole company. So everybody has his own specialism. One guy is specialist in software, another in power supplies, and another in DAC design. And together we form a great team. And that's why the LS1 not just sounds neutral, but also natural and musical, because it's not just a matter of making stuff flat. It's also a matter of being careful how you do that. Technically speaking, you enter the LS1 digitally from, let's say, an MU1 with an AES EBU input. And then one channel is taking off from that, and there's a second cable going to the other loudspeaker. The volume control is in the digital domain, and you remotely control it from an MU1 or the LS1 remote. Of course, if you have an analog source, you can connect it directly on the LS1s, because there is an analog input and there is an analog to digital converter that takes that signal to the digital domain. And then after that input, first we apply the corrections to the drivers, then we apply crossovers, we apply a phase correction of the crossover, because that's one of the things that you cannot do in analog, but you can do digitally. If you have a fourth order crossover, you will end up with an all-pass filter phase characteristics. And it's impossible to correct in the analog world because you need delay, but in the digital world, delay is no problem. And with that delay, we can apply a phase correction of the crossover. So you'll end up with a straight amplitude response on the crossover, but also a straight phase response. And we can do that both for the tweeter to woofer crossover and for the subwoofer to woofer crossover. So that's still digital domain, of course. And then there's a volume control still somewhere. And then you go to a DAC, and that's a DAC per driver. And the DAC is connected to an amplifier. It's an amplifier per driver, of course. And then we connect to the drives themselves. And there's another advantage of using an active system, because the connection between the amplifier and the speaker can be done in a different way than the standard way, because we don't need to comply with a certain standard like an 8 ohm connection or whatever you can do, not just voltage drive. You can partly do current drive and stuff like that. And that's especially true for the SB1 subwoofer. We mount a sensor on the cone, and the information of that sensor is sent back to the amp. So the amplifier actually knows the real sound pressure that the loudspeaker is generating, which can be slightly different from the original input signal because the loudspeaker will have some distortion. Now, by comparing the analyzed sound pressure level turned into an electric signal, comparing that to the original input signal in a feedback system, you can attenuate the distortion of that system. And in the SB1, we achieved 25 to 30 decibel, which is a lot, because this motion feedback system, as it's called, was introduced by Philips in the 70s here in Eindhoven. And they had mass market, and they needed to have everything safely organized so that it will always work well. And in our case, we are able to calibrate every single driver and make sure that everything stays stable. And because of that, the Philips system had about 10 dB of distortion reduction, and we have 25 to 30 dB, which is a lot more. And that's the beauty of active systems. You can do stuff like this by sending back the analyzed signal, by using current drive, by using an amplifier that's well matched with the driver, the loudspeaker driver. Correct for maybe a cabinet that looks a little small. The SB1 is a pretty small box for a low-end loudspeaker. But it's possible because the nonlinearity that occurs from using such small enclosures is compensated by the feedback system. So we don't have any problem with that. And therefore people think, okay, it's a small box, but then they hear it and think, wow, that's a lot of bass. Yes, it's linear all the way down to 15 hertz. So you bet there is bass. And that's the advantage of using active electronics. It's impossible to do it with passive electronics. You will end up with huge cabinets to achieve similar frequency responses.
And I think with the LS1s, they've got a very good off-axis presentation as well.
Yeah, that's actually part of that acoustic design, with the width and the rounded edges of the legs, the small horn that we used on the tweeter, the selection of the woofer, etc., the selection of the crossover frequency. Everything together blends into a loudspeaker that has a very linear off-axis response and very gradually falls off. But it's because it's a wide baffle, it will project the sound in the room. So one of the most wonderful assets of the LS1 is that it's a speaker that works perfect in a very big room where you need the projection to help you, and in a very small room where you can, like here, you can place the speaker almost with the back against the wall, and there will be no null in the frequency response because of that. Because if you have a standard speaker, it's deep, so the wave travels around the speaker, reflects to the wall, comes back, and then is in counterphase with the wave or the sound that still comes from the speaker directly. And so you will get a dip in your frequency response. But due to the fact that the LS1 is wide but not so deep, the wave that travels around it immediately bounces back and is still in phase. So you can use it in small rooms, you can use it in large rooms, and because of the off-axis response and the fact that it radiates more sound to the front than to the sides, you can use a toe-in angle and attenuate the reflection on the side wall, so your stereo image becomes much clearer. It's actually relatively easy to place a pair of speakers in difficult rooms. Of course, the frequency range below 200 hertz will still take the attention of the installer. That's just physics. But with the motion feedback sub, you have much less energy that you're putting in the room, so you have much less problems of the room mode to start with. And so again, that makes it more easy to place the loudspeakers in the room.
With the control with the iPad software, you give the user the option of the way they position the loudspeakers in the room. So either directly at the listener or crossing over. So is it 45 degrees and 30 degrees?
Yeah, 30 is the standard setup where the distance between the speakers is the same as the distance from one speaker to the listener. That's the ITU standard. So that's also used in studios. So if you want to hear how the mix was made, you need to sit at that position. It's an equal sided triangle. So that's where the 30 degrees stems from, because then it's a 60 degrees in total angle, and that's 2 times 30 degrees. So, but then they aim at the listener, and if you slightly turn and toe in, you attenuate the side reflections from the nearby speakers, so your stereo image usually gets a little better. In some rooms it doesn't work. You can even turn toe out if that's your preference, and then you can also use the same 45 degrees setting, because what we actually do is, if you're not on axis of the speaker but slightly off axis, the high end rolls off slightly, and we correct for that in an EQ. So it's just an EQ setting.
And with the SB1 subwoofer, that fits really neatly into the bottom of the loudspeakers. But if you've got a difficult room, you can move that away from the speaker and perhaps put it somewhere else behind the speakers or in a different position.
Exactly. That was the point I just wanted to make, that the fact that we have a separate box for all the frequencies below 70 hertz makes it possible to place the main system at the optimal spot for a good stereo image, or maybe just because they fit well in between the furniture of your living room. And then that might not be the optimal spot for the most linear low frequency behavior. Maybe you are just at a difficult point for room mode. And if you would then have a full range system that has to stay there, people tend to start EQing stuff and room mode EQs, etc. And usually it doesn't really improve things as much as you would wish you would get. So a better solution then is to either apply acoustic treatment or take the subs off from the footplate and put them in a place where the subs address the room modes in a more linear way, and it can be perhaps just 30 centimeters away from the main system, but that's already acoustically different. And with our system, you have that freedom. If it's a full range floor standing system, you cannot take the subs apart from the main, so you will have to move the whole system until the best compromise is achieved. But we have the possibility to have the main system at a place where the bass is not so good, and then you take the subs from the footplates and put the bass below 70 hertz at the spot where the bass is really good, and then you have the best of both worlds.
Eelco, thank you very much. I should say at this point that if you're in the Surrey or Home Counties area, you're very welcome to come in and have a demonstration of the MU1 and the LS1B speakers with the SB1 subwoofers. If you'd like to have a listen in your own home, we'll come to you, and that's probably a good place for you to have a listen in your own environment. So Eelco, thank you very much for joining me for the second time, and I wish you every continued success with Grimm Audio.
Well, thank you so much, Steve, for having me, and I enjoyed myself a lot. It's always a pleasure to see you.
See you again soon. Thank you.